Let's discuss a question on machine design. We have been given a single plate clutch which is effective on both sides and which transmits a power of 25 kilowatt. Okay, so and the speed is given, which is 3000 rpm. Okay, so based on this, actually these two information, we can find out the torque that is coming on the shaft, okay, or the torque that the clutch surfaces have to transmit. So we know that the power is nothing but torque into omega, and omega can be written as torque into 2 pi n by 60 is equal to P. So the torque basically can be written as 60 P by 2 pi n. Okay, and so based on the information, 60 P is 25 kilowatt, n is 3000 rpm. We get torque to be 79600 Newton mm. Basically in meters we get it 79.6, and then we convert into mm because we want ultimately the answer to be in mm. So this is the torque. Now here it is given that use the uniform wear theory. Now there are two theories of analyzing clutch. One is for the new clutch and other is for the theory which is for the new clutch is basically the uniform pressure, because you have a flat contact and it doesn't wear out, whereas for the old clutch we use the uniform wear theory, which basically has the following set of equations. I'll just write on the equation. The Pmax, the maximum pressure intensity occurs at so let's say you have the clutch like this, okay, and let's say the inner dia is R1 and the outer radius, the inner radius is R1 and the outer radius is R2. Outer radius is R2 and the inner is R. Okay, so the Pmax, intensity of maximum pressure occurs at the inner radius, where the outer decays as you look for the older clutch. As you look at the older clutch, so Pmax into R1 is constant. So this is one of the equation that comes from the uniform wear theory. Another equation, the expression for the load, actual load that is supported by the clutch. So that is 2 pi C, the same constant, into the outer radius. Okay, okay, the outer radius, which is R2 minus the R1. Okay, this is the intensity, this is the actual load, and the expression for the torque. So these three equations have come from the derivation for using the uniform wear theory. So N, mu, W and the R mean. So N is number of effective sites, which are 2. So 2, mu is coefficient of friction, W is this actual load, and R is the mean radius, which is small r1 is capital R2 by 2. Okay, so the other information that is given in the question is that the outer radius, outer to inner diameter is 1.25. So basically the ratio of the radius also will be 1.25 R1. Okay, so we use the first two equation. The Pmax intensity is given. Well, it can support a maximum pressure of 0.1. So 0.1 into R1, which is the inner radius, is constant C. Now this we'll be using in this W. So we get W as 2 pi, C is 0.1 R1, and you have R2 minus R1. R2 is 1.25 R1, so it becomes 1.25 R1 minus R1. So the value of W you'll be getting is 0.157 R1 whole square. Now this obviously I have to use in the torque expression, because we know the total torque which we calculated before, which is 7960. So 796, and effective sides are 2. Mu is given as coefficient of friction is given as 0.255, and W is 1.157 R1 whole square, and R1 plus R2 is also so R1 plus R2 by 2, R2 is 1.25 R1, so it becomes 2.25 which is by 2, which is 1.125 R1. So we get the entire expression in R1 cube. So if you find out this R1, we get R1 as 96. By solving this you will get 96 mm, and therefore we need to find out, let's see what we need, the outer diameter. So R1 is the inner diameter, so R2 would be 1.25 times of this 96, which is nothing but 96 plus 1/4 of 96, which is 24, so it becomes 120 mm is R2, and the diameter obviously would be twice of that, which is 240 mm, the outer dia. So this is the outer dia, and the option, let's see, we have the options for this. Let's see which matches. Okay, so 250, 240, so option A is the answer, 240 mm. Thank you.